One CPC project, One Chip Personal Computer, Part 5, by Dr. and Engineer Economist Robert-Bela. One CPC proposal, summary of Part 5. One CPC processor, x86 and ARM. One CPC processor, instruction sets. One CPC processor, TDP. One CPC processor, x86 and ARM examples. One CPC processor cache. One CPC IMC, the integrated memory controller. One CPC internal RAM memory, L4. One CPC internal non-volatile memory. One CPC graphics processing unit, GPU. One CPC local area network, LAN. One CPC periphery control, I/O pin control. One CPC drivers. One CPC audio and video playback. One CPC USB ports. One CPC extension ports. One CPC storage extension slots. One CPC processor, x86 plus ARM. As described before, the one CPC concept is based on both architectures, x86 RISC and ARM CISC processors. In this way, a better energy consumption per computational power results can be obtained by simple operations being done by the ARM microprocessor and complex ones done by the x86 core. One CPC processor instruction sets. About the instruction sets, the instruction sets including SSE 4.1 or SSE 4.2 instruction sets would be ideal, but MMX to SSE 4.1 or SSE 4.2 included. In a more realistic scenario, the instruction sets from MMX to SSE3 would be enough good too. It means SSE3 included. Special, it means direct hardware and instructions will be necessary for add, subtract, multiply, divide, add and multiply operations. One CPC processor, the TDP. TDP of one CPC should be between 2 to 5 watts and at need reduce the internal clock frequency to, let's say, even 10 MHz, so the power consumption and the generated heat would be reduced. In this case, it would become implantable. One CPC should have some thermometer diodes in the structure, so it will not freeze because of the temperature, like the old generation of microprocessors. One CPC processor, x86 and ARM examples. The ARM 32-bit processor, maybe even the first 32-bit ARM microprocessor architecture will be good enough for this purpose, or obtaining ARM v6 architecture would be ideal for this design and simplifying it. On the x86 slide, the Pentium 3 12-tin or equivalent or newer would be good. I mean any x86 architecture. By incorporating the ARM RISC and the x86 CISC architecture, their good parts could be used. RISC is simple and has fixed length instructions. CISC, it is simple to program. Hardware optimizations for the very much used instructions will be needed in time. One CPC processor cache. L4 cache, meaning the RAM memory of 64 MB or even 128 MB maximum capacity could be used in one CPC chip. Only L1 and L4 level cache, it means the RAM memory, would exist in one CPC. No L2 or L3 level cache memory in one CPC designs would be used. One CPC, the IMC, integrated memory controller. The IMC, integrated memory controller, in one CPC would be designed as a fixed structure with a maximum of 128 megabytes L4 capacity to control and having some hardware optimizations for it. IMC's working frequency would be equal with the processor's frequency. That means faster reaching and or use of L4 would be realized. The data bandwidth in data bus would be 32-bit wide only if the GDDR5 architecture is used as L4. One CPC, internal RAM memory, the L4. 64, 80 megabytes, 986 or 128 megabytes maximum L4 cache RAM memory would be realized. The video memory would be 8 megabyte, 12 megabyte or 16 megabyte maximum from the L4. The L4's frequency would be the processor's frequency, half of it or 1/4 of it, for energy consumption reduction. Memory hierarchy, L0 meaning the registers, L1 cache, operative memory, the RAM memory, named also L4. Cache latency reduced in one CPC. Having higher speed is better than low cache latency, but in one CPC the latency has to be reduced. The frequency is not so important parameter here, and it consumes more energy. In the cutting-edge computers the memory speed is increased. One CPC, internal non-volatile memory. An example for the numbers of transistors from the non-volatile memory, flash memory. 64 billion transistors are needed for 128 gigabit capacity. It means it's equal with 16 gigabyte memory. This capacity would not be needed in one CPC chip. Probably 64 megabyte memory would be enough, meaning about 256 million transistors only. One CPC, graphics processing unit, the GPU. The integrated VGA driver should be DirectX 9.C compatible. It can be an older VGA processing unit architecture or a new one with reduced number of processing cores or execution units, EUs. Third generation of video processor, transform and lighting and vertex and shader would be used. Ideally, shader model 4.0 or the latest generation of GPU would be used. The integrated GPU should be DirectX 9.C compatible. If GPU cores will be used, then only 1 or 2 cores only would be used in case of the latest generation VGA processors. GPU from ATI, NVIDIA and Mali. One reduced core from each architecture, but each with the full instruction set. The integrated GPU's video bit depth would be 32-bit or 24-bit, existing also a grayscale video mode and a 256 color video mode. One CPC, local area network, the LAN controller. The integrated LAN controller would be limited to 10 megabits per second only. It is maximum 1.25 megabyte data transfer per second. In most of the world you don't have even this effective speed of the internet, so it would be enough. Another reason is the goal for reduced power consumption. Any old or new LAN controller could be used for this purpose at 10 megabits per second speed only. One CPC, periphery control or input-output I/O pin control. All the periphery controller circuits, I/O controller, will be integrated in the chip. On one CPC maybe will be integrated the Wi-Fi, but no Bluetooth controller, offering instead USB support for them for sure. One CPC, drivers. One CPC should have specific optimized drivers for its architecture, for its system. The 1CPC GPIO ports should be reprogrammable outputs, so any other external cards or extensions could be connected. 1CPC audio and video playback. Flash player and YouTube FLV format should be hardware accelerated. Only MP3 and WAV formats used as audio files or audio playback in the first generation of 1CPC would be used. H.264, DivX, MPEG-2, MPEG-4 and 3GP video hardware acceleration is also needed. For example, AMD's UVD, that means Unified Video Decoder 3.0 system or simplified, at around 640p resolution, but not higher than 720p resolution. This UVD is good for Full HD video playback, but it's needed, it will be reduced, it will be simplified for 640 or 740p resolution. The UVD motor can be used also as a processor, a coprocessor, for or in some special applications or cases. 1CPC, the USB ports. 1CPC project should exist the USB port 0 and 6 or 8 USB ports on the motherboard, depending from the motherboard manufacturer. 5 electronically connected USB ports should be used by 1CPC chip. The programmer USB port being USB 0 and the other 4 standard USB 2.0 ports. The programmer USB port would be a special port, separated from the other USB ports. USB 0 should have access to the non-volatile memory by a 12 hex key, hexadecimal, please observe the link. 12 hex key code for the end-user chips or 24 hex key code for the medical category chips. The extension ports number and type would be limited only by the PCB board's size where the chip is placed. One SATA port on the 1CPC compatible chip is presented. For example, a SATA controller can be integrated this way by other chip makers in their designs. Example of use of the GPIO ports of the 1CPC chip. The SATA connector would be soldered manually to the board using the THT, through-hole technology hose. Description of the THT can be found at the next link. 1CPC storage extension slots. The 1CPC chip should have 2 microSD extension slots for storage, 2 slots for safety. The SD controller should be microSD-HC card compatible. End of part 5. Thank you for watching.